Okay, so let's look at the Hydrates Lab, or the dehydration of a salt. So this is lab 3, and here's some sample data. So in this lab, what we did was we had a crucible, and we put some hydrated copper 2 sulfate in there. We heated it up. We measured it, we weighed it, we heated it up, and then we weighed it again. And then now what we want to do is figure out how much water was actually attached to this hydrate. How many, what is the X in this number here? What is the mole ratio of the copper sulfate and the water? So let's analyze this data here, some numbers. So this first number here, this is just the mass of the crucible and the lid. So that's just the crucible and the lid. And then this next one is with the sample, and that sample is the copper sulfate with the water. That was before we heat it. And then when we heat it up, we're assuming we're driving off all the water. So what we have left here is the crucible and the lid and just the copper sulfate with no water. So if we want to find the mass of the sample, and it tells you right here, line 2 minus line 1, line 3 minus line 1. So they kind of give you all those things there, but what does this actually mean? So the mass of the sample there, that's just the copper 2 sulfate with the water, right? Sample is everything. It's the copper 2 sulfate with a certain amount of water. The residue is just the copper 2 sulfate. And then the water is just the water. So if I added up 5 and 6, that has to equal what's in row 4. So this is the copper sulfate with the water. This is just the copper sulfate. So that's like after I heat it up, what do I have left? And then this is just the water. So residue is just the copper sulfate without the water. The sample is with the copper sulfate and the water. All right, so how do I find this one? Find the sample. I'm just going to do 2 minus 1. So I have my 46.7 minus 43.3. 46.7 minus 43.3 gives me 3.4. Great. And then the mass of the residue. What's the mass of the residue? I'm going to take 4. So this is 45.4, and subtract out the crucible, 43.3. And that gives me 2.1. All right, so I think does that kind of make sense? So this is, I'm going to take the 2 and 3. So it's the crucible and the lid before heating minus the crucible and the lid. Okay, so that's just going to give me the whole sample with the water. And then after I heat it up, I'm going to take the crucible and the lid after heating minus the crucible and the lid, and I should just have the copper sulfate left in there. Great. And then to find the water, I can take the difference between, there's a bunch of different ways actually. I can take the difference between these two. That's fine, between 3 and 2. So 46.7 minus 45.4, 1.3. I could also take 3.4 minus 2.1 to get 1.3 as well. The percent of water. So how do I find the percent of water in the sample? I've got the amount of water over here, those grams of water, 1.3, divided by the mass of the whole sample. So that's over here. So this is the copper sulfate and water. So it's basically water over copper sulfate and water times 100. So this is 3.4, and that should give me the percent of water, which I got to be 38.2%. Now the last part is the hardest part. So the last part, I want to give myself some space here so we can write it out. What I want to do is find, this is basically an empirical formula problem. I want to find the moles of copper 2 sulfate and the moles of water, and then I'm going to divide by the smallest number of moles. I'm going to get that mole ratio. So I have to find both of these. So I'm going to start with the 2.1 grams of the copper 2 sulfate. So I have copper 2 sulfate. I'm basically focusing on these two right here. I've got my copper 2 sulfate. I've got 2.1 grams of CuSO4. And I want to convert that to moles, so I need to find the molar mass. So the molar mass, I'm going to give that to you for copper 2 sulfate is 159.6 grams per 1 mole, and I found that by just taking the mass of copper plus the atomic mass of copper, atomic mass of sulfur, 4 times oxygen, add them all up, and that's what I get there. So to find the moles of my copper 2 sulfate, I've got 0.01315 0.58. You can put any one you want there. We're gonna eventually round after we find our mole ratio. And I'm gonna do the same thing for water. So I'm gonna take this amount of water, the 1.3 grams of water. I'm gonna convert that to moles. Molar mass of water is 18.02 grams for 1 mole. That's probably one that eventually you'll memorize because we do water so much. When I 1.3 divided by 18.02, I got 0.0722. Now I want to find the mole ratio. So I'm going to divide by the smallest number of moles. Who has the smallest number of moles? It's the copper 2 sulfate, sure. So 0.013158, that's going to give me 1 there. And 0.013158 ends up being about 5.5 or 6 here. 5.5, I'm going to round that up to 6, so I got 6. Okay. So the value of X in there is 6, or you can say I have CuSO4.6 waters. That's fine. Right, so you may get a slightly different number. That's okay. Just work out your numbers and see what you get. And then answer those post-lab questions. So how would you test an unknown crystalline compound to determine if it was a hydrate? Basically, just describe what we did. What did we do? We put it in the crucible, we heated it up, we drove off the water, and then if the mass changed, then it had water in it. If the mass doesn't change, then it didn't have water in it. And then I want you to think about this one. What would happen if you didn't heat it long enough? How would that affect your percent of water? Would it be too big? Would it be too small? Would it be not affected at all? So I want you to think about that. I'm not going to give you the answer. So really, for this lab, we're collecting 3 masses. That's it. The mass of the crucible and lid, before you heat it, after you heat it, and then just working up a couple numbers here, which again, they're listed for you right there. And then the only tricky part is really this one, just converting to moles, convert this guy to moles, and divide by the smallest number of moles. Copper sulfate is always going to be the smallest number of moles. So because you're going to get more than 1 water, because you're attaching water is like part of the crystal structure here.